compared to the parent graph of a parabola? How's that? Stretched vertically. So it's usually taller and skinnier, right? Versus if the absolute value of this number is less than 1, so, 1/3 or -1/3, either of these cases is going to be kind of vertically compressed, so it's going to look shorter and fatter. So here's the parent graph. This one would look like this. And if this is the parent graph, that stretch would look like that. Does that make sense? Okay, taller and skinnier. And that has to do with the size of A. If the absolute value of it is greater than 1, then it gets taller and skinnier. If it's less than 1, then it gets shorter and fatter. Okay? So the same is true for the A on the other form, which is kind of in your simplified polynomial form. So the benefit of this one is obviously the HK, the vertex, which is an incredibly important point, is right in front of you. Versus when it's a polynomial, HK, the vertex takes a little bit more work. The same features of A are true, though. If A is positive, it opens up. If A is negative, it opens down. The one benefit of this polynomial form is that it gives you the y-intercept. Okay? Does that make sense? All right, and this one does not give you the y-intercept. So this one gives you the vertex, this one gives you the y-intercept. Thank you. So starting with one that's in that kind of vertex form, it's funny, your textbook does it differently, which is why this one does, but I call this one vertex form for obvious reasons. It gives you the vertex. So the first example we're going to sketch a graph for is in vertex form. What is the vertex? What is the coordinate pair for the vertex Maria? 3, 8. Good. Does it open up or open down, just out of curiosity? Down, because that's negative. So 1, 2, 3, 5, 6, 7, 8. So there's my vertex. And I know it's going to open down. So second to the vertex, or kind of in alignment with the vertex, the next most important points are your x-intercepts, your roots, your zeros, however you want to say it. You always find x-intercepts by setting what equal to what? Y equal to 0. So x-intercepts, you set y equal to 0. So if I set this f of x equal to 0, -2 x minus 3 squared, and then solve for x. So that's going to happen by subtracting 8 from both sides first. So -8 minus 8. I'm going to get -8 equals -2 x minus 3 squared. Divide both sides by -2. I'm going to get 4 equals x minus 3 squared. Square root of both sides. What is that going to give me? Haley. Perfect. Equals x minus 3. Good. And then when I add 3 to both sides, Michelle, what is that going to give me? Five and 1. Very good. +2 plus 3 is 5, and -2 plus 3 is 1. So my x-intercepts are 1 and 5, which should always be equidistant from the vertex. So 1, an x-coordinate of 1 would be 2 units to the left. So there's my x-intercept, 2 units to the left, and 5 is 2 units to the right. So there's that symmetry that exists surrounding the vertex. What is the line called that goes through the vertex? You'd usually see it kind of like dotted. Axis of symmetry. Good, that's what's written below. So that's always the x-coordinate of your vertex. So when they want the axis of symmetry, they're looking for the equation of a line. So you need to write x equals, and then whatever number the x-coordinate of your vertex is, 3 in this case. X-intercepts are 1 and 5. And then the next most important point, which will sort of just then round out your parabola, is the y-intercept. If to find the x-intercept you set y equal to 0, then to find the y-intercept you set x equal to 0. So negative 2 times 0 minus 3 squared plus 8, little order of operations there. Negative 3 squared is 9 times negative 2 is, plus 8 is negative 10. Now, the y-intercept, I'm going to write down that it's negative 10, but for obvious reasons, my graph is not big enough. I'm not going to draw this to include negative 10. But I do want to talk about that symmetry again. If the point 0, negative 10 is on my graph, what are the coordinates of the point that's symmetrical to that? If 0, negative 10 is on my graph, what are the coordinates of the one over here that will be symmetrical to that? 6, negative 10, right? So we're double the distance away from the axis of symmetry. So we're 3 units away to the left to get our y-intercept. We would need to be 3 units away on the right-hand side to get the symmetrical point to that. So 0, negative 10, and then over 3 more would put us at 6, negative 10, if we were rounding this out. Okay? Any questions? All right. Now, if something is not in vertex form, if it's in that polynomial form, how do you go about finding the vertex here? Steven? You could complete the square. How else? There's 2 ways. Anybody know? Okay. So before I review completing the square, I'm going to teach you the other way because it seems like it's going to be a little bit newer to you. There is a formula, a little quick thing that you need to memorize that will always give you the x-coordinate of your vertex. Okay, so maybe we'll write it at the bottom here where you can actually see better. X-coordinate of your vertex comes from negative b over 2a. That, if you do that real quick, that will always give you the x-coordinate of your vertex. So in this particular case, the x-coordinate is going to be negative b, which will be negative 4, over 2a, which 2a is negative 2 here, and negative 4 divided by negative 2 is 2. If you know an x-coordinate, how do you then, what's the next step away to find the entire coordinate? Plug it in. So if we plug in 2, we're going to get negative 2 squared plus 4 times 2 plus 1. What's that? 5. 2, 5 is our vertex. Have you ever done that? Negative b over 2a? Yeah. It sort of comes from the quadratic formula, because the quadratic formula, just to remind, looks like this. There's your negative b over 2a, right? So if you were to split this up, kind of like you guys were asking on your homework last night, if I did negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a, here's your vertex. And then this plus or minus, if you kind of think about your vertex, the plus or minus is going to get you to your x-intercept on the positive side and your x-intercept on the negative side. Does that make sense? Kind of tells you really how wide that's going to spread, how far to the right and how far to the left of your vertex you're going to go to get your roots. Okay? So there is a strong connection with why this formula is negative b over 2a with your quadratic formula. Okay? There's also a way via calculus that we will talk about again why that negative b over 2a works, but we're not really quite ready to do that until March. So at any rate, there's our vertex. The other way to find your vertex, as was it Stephen, did you originally say this, would be to complete the square. So let's review that. If I have f of x equals this as my polynomial, what's the first thing I need to do to complete the square? Take out the negative from just the first two terms, though, right? We just factor out that negative because you can't have a coefficient from just the first two terms, so it's going to leave x squared minus 4x in parentheses, and then you guys keep the plus 1 at the end. Does that look right? You remember this? What number in here, Zach, would complete the square? Half of negative 4 is negative 2. Negative 2 squared is 4. So you're going to add 4 in here. Okay. Here's the trick here with the factored out part that you have to remember. Even though I added 4, it was in a set of parentheses that has a negative out in front. So what did I really do to this equation? I technically subtracted 4. So in order to keep things all equal, if I subtracted 4 here, I need to add 4 back to this side to make sure it's not been changed. So again, I'm changing the appearance, but I don't want to change the value. So the fact that I added 4 in a set of parentheses that had a negative out in front means I really subtracted 4. So to counter that, I have to add 4. Does that make sense? Are there any questions on that? Okay, so now I have my negative. This is going to factor into x minus 2 squared plus 5. This pencil is going to be the death of me today. I think it's cracked about 7 times in this short 15 minutes. And from this format, we now see that the vertex is 2, 5, like we found before. Which way do you like better? Completing the square? Is that because you're just used to it? Okay. Right. But it's a lot more work. No? More room for error? Depends on how good you are at. Some kids don't like completing the square at all, and they're not very good at it. So this is easier, but whatever you want. Yeah. Say it one more time. Let's see. If you took it out of everything, maybe that would show us why it's not going to work. If you did take it out of everything, now when it comes time to complete the square is where you have an issue. The whole goal is to get your trinomial to be a perfect square trinomial. So when we just take the negative out of the first two terms and we're looking to complete the square on this trinomial, you take half of that and square it, right? I guess if I were to, what I need this number to be is still a positive 4. So I would, if I want this to be a positive 4, I would need to add 5 in here to make it a positive 4, right? Half of this is negative 2, squared is 4. So I need this number to be a positive 4. If it's already a negative 1 and I've left that there, now I've got to think a little bit harder about what I need to add there to make it become the positive 4 that I want. Does that make sense? So if I added 5 in there, but there's a negative out in front, I truly subtracted 5. So I'd have to add 5 back to get it to be the same and not change the value. So it can be done. It's just there's an additional step of thinking that has to be done if you do leave it in there. Does that make sense? So I guess the answer is you don't have to, but it's just the way we teach it because it kind of takes off a layer of thinking to just leave that out. That way, whatever the magic number is that you need to complete the square, you can just add in there and not have to think about how it's going to counter with what you left there. Make sense? Okay. So there we are with our vertex. Our x-intercepts, we said again, were to set y equal to 0. Yes? So it's up to you now. If you've decided to complete the square and you have this equation written, would you rather set y equal to 0 in the original or y equal to 0 down here? What do you think? Let's do it both ways. If I set y equal to 0 up here, what's my method for solving that? Quadratic formula, probably. If I set y equal to 0 down here, my method of solving is just by square root, right? I can isolate this, so I can subtract the 5 over. I'm going to do this one because I think it's easier. I can divide by a negative on both sides, so 5 will equal x minus 2 squared. I can take the square root of both sides, which will be plus or minus root 5 equals x minus 2. And then add 2 to both sides, so x will equal 2 plus or minus root 5. So, and that's the same answer you would have gotten if you did your quadratic formula. But do you see how that first number, 2, is where our vertex is? 2, 5? Yes? So to get to my zeros, I'm at 2. I need to add root 5 and subtract root 5. Now, approximately, because we don't have a calculator, what is the value of the square root of 5? 2 point something? Is it a 2.9 or is it a 2.1? What do you think? It's closer to 2.1, right? Because we're just post square root of 4, which is exactly 2. So the square root of 5 is going to be a 2.1, 2.2. The reason we don't care too much about the exact value is because even if we knew it, you'd sort of be estimating where you graph it anyway, right? So if I start at 2, and then I do plus or minus like a 2.1-ish, it's going to put me slightly after that line, and 2.1-ish is going to put me slightly prior to the y-axis. And my x-intercepts, if I fill in up here, 2 plus or minus root 5. The axis of symmetry is what? Josh. What is it? Y equals 2 is the horizontal line. X equals 2, but it's always x equals. X equals, which should make sense because you're taking the x coordinate. So there's, usually we draw that in as a dotted line. And then our y-intercept is what? 1, right? Because we have this also in that polynomial form, that 1 is just your y-intercept. So we can plot that. So what is the point symmetrical to that? What are the coordinates of the point on the parabola that's symmetrical to that one? Winter? 2, 1. 2, 1. Oh yeah, 4, 1. You're right. And then that gives us a nice rounded out parabola. Good? Any questions? Yes. Is this 2.2? Oh, this is where the maximizing questions come in. You have 100 yards of fencing to enclose a rectangular region. Find the dimensions. So if I label one side X and the other side Y, the fact that I have 100 yards of fencing is going to give me one equation. What will that equation look like? Ellie? Good. 100 equals 2x plus 2y. It's like a perimeter. And then we want to maximize the area. So if whatever equation you're looking to maximize, that's what you need, or whatever thing, I should say, you're looking to maximize, that's what you need to write an equation for. So area equals, and what's the equation? Just straightforward for the area. Michelle. X times Y. Okay, and I'm going to star this one because this is the one we're maximizing. So this is the one that we need to get all in terms of one variable. Okay? So it really doesn't matter here. We'll adjust either way. But we need to either substitute out the X or substitute out the Y. So we're going to use our other equation to solve for one of those two variables. So let's just, for the sake of grabbing a random one, let's solve for X. So we'd subtract 2Y and divide by 2. So X equals 50 minus Y. And then we're going to use that to plug in over here. And then to maximize this, first of all, if I were to distribute this through, this is a what? Parabola, right? And it's a parabola that opens up or opens down? Down. And what point maximizes this? What point on the parabola is of most interest to us for maximizing? Vertex. So if we had our calculator, we would second trace, we would find the vertex. Since we don't have our calculator and we just worked on this on the front side, how do you calculate your vertex? Negative b over 2a. So if I want to make this a little bit clearer, I can switch the order there. So negative b over 2a is going to be negative 50 over negative 2, which is 25. That gives me the x coordinate. Now here's where this is going to be maybe a little confusing. What? 2a. A is negative 1. So 2a is negative 2. So this x coordinate of my vertex is 25, comma, we get the y coordinate by plugging that back in, right? So if we plug 25 back in, it's probably easier to plug into here, right? What's 50 minus 25 times 25? And do you know what 25 times 25 is? Good, 625. So this is the parabola that we graphed. So this is where it gets a little confusing. The x coordinate of 25 that we got is the y dimension of our rectangle. Maybe I should have called my rectangle A and B instead of x and y, and it wouldn't have been so confusing. But the x coordinate here, because our input is our y's, so that 25 is your y. The output is our area, 625. So if our y coordinate is 25, our x coordinate is 50 minus 25 is also 25. So the dimensions that maximize the area, 25 by 25. The area, 25 times 25 is 625. Stephen. That gives you the x coordinate, or the input, we should say, better here. Because it's okay, so you would get lucky here and it would work only because x and y are the same number. But in the event that they're not the same number, when we are finding negative b over 2a, it's giving us the, we'll say, input for our vertex of this parabola. And the input is y here. So when we do this, even though this is the x-axis, this is our y input number as well. So that's why I said I made it confusing by calling it x and y. If I called it a and b, it wouldn't have seemed that confusing. So if I called this a and this b, and I did a times b, and I did, well, a equals 50 minus b. Then I plugged 50 minus b in. Now my coordinate would be b comma a. The b is the input and the a is the output. Does that make sense? And then if I do, of course now there's a's and b's with negative b over 2a, but not as big of a deal. This gives me the input number for my vertex. So that gives me the b dimension of 25. And then I plug 25 back in to find the area under that condition. And then that brings me back to filling in kind of the rest. Jayla. Because if I know that this input b is 25, then I can go back here and 50 minus 25 makes a 25 as well. Does that make sense? Go back to your substitution, the thing that you used for substitution, that will give you the other variable. So there's three unknowns floating around. The dimensions, a and b, and the area that maximizes it. Anything else on that one? Okay, and here's one of our other types. Car rental agency rents every one of its 200 cars at $30 per day. For each $1 increase, five fewer cars are rented. Find the rental amount that will maximize the revenue. So always kind of have your eye on what is it that we're maximizing. And whatever it is that you're maximizing is what you need to write an equation for. So we're maximizing revenue. We need to write an equation for revenue. And this is where the revenue currently is 200 cars times $30 per day. So number of cars, price per day. So currently the revenue is $6,000 a day. They find out, or after like experimenting a little bit, they find out that for, on average, every time they increase the price by $1, so increasing by $1 X times, they rent 5 fewer cars, so minus 5X. Any questions here? Let's talk about another way to find the vertex from factored form. If a quadratic is in factored form, what does that make it easy to find? The x-intercepts, because you would like tee it up, right? So if I tee this up and I set 200 minus 5x equal to 0, divide both sides by 5, I get one x-intercept to be 40. The other x-intercept is negative 30, right? So how does that, if I have an x of 40 and an x-intercept of negative 30, how does that make it easier to find my vertex? My vertex is always going to be where relative to those two? Halfway in between. So what is halfway in between, aka the average of 40 and negative 30? The average. Add them up. You get 10, divide by 2. 5. So I now know that my vertex is at 5 something. Okay, so here's 5. So that's my axis of symmetry, right? There's my little dotted line through that. And then if I wanted to know exactly what, I would do what with my 5? Plug it in, right? So if I plug in 5, 20 minus 5 times 5, so 200 minus 25 is 175. Times, if I plug in 5, I get 35. So ideally, to maximize my revenue, I want to sell rent 175 cars at $35 each, and that will give me 175 cars times $35 will give you your maximum revenue. So this is not something you're going to be able to do in your head. You're going to have to do some long multiplication. Remember how to do that? 5 times 5 is 25. Carry your 2. 5 times 7 is 35. Add your 2, you get 37. 5 times 1 is 5. Add 3, you get 8. Fill your 0. It's been a while, huh? 3 times 5 is 15. Carry your 1. 3 times 7 is 21. Add your 1, you get 22. Carry your 2. 3 times 1 is 3. Plus 2 is 5. 6,125. So find the rental amount. If X was 5, our rental amount was $35 to answer their first question. What is the daily revenue under those circumstances? $6,125. Okay? So from that factored form, without a calculator, it doesn't necessarily make sense to multiply this through anymore. Because take a look at, if I had done that, I would have gotten 6,000 plus 200x minus 150x would be plus 50x minus 5x squared as my revenue equation. Now, you can do negative b over 2a on that if you want to. You can complete the square on that if you want to. Or you could kind of use your zeros to capitalize on the fact that the vertex is always halfway in between. Does this make sense? So really, 3 ways now I think that we can find the vertex. Depending on what format it's in is going to kind of dictate what's most efficient. And then there's a 4th calculus way of finding the vertex. Is that all coming together? Rounding out your understanding of all this? All right, so homework is there on your homework to the best of your ability. I guess you're going to kind of have to look at the answers to know what's practical and not. If your answers are whole numbers, really try hard to do all this without a calculator, right? But I can't promise they're all nice whole numbers. So if you look at the answers and they're a weird decimal, then you probably should just type it into your calculator and do second trace. But I can answer those questions on Monday. Should I have used a calculator, or should I be expected to do this without a calculator? I can kind of clarify that on Monday once you take a look at the questions. Okay?